Good morning, students. Am I audible? Am I audible or not?
Yes.
Good morning, sir.
Good morning. Just wait
Good
2
morning,
minutes.
sir.
Good morning. Just wait 2 minutes for rest of the students to join in this session. Then we will continue the session.
Good morning, sir.
I think now whiteboard is visible for all of you. It is visible. Hello.
Yes,
Yes.
sir.
Okay. Just 1 minute. Hey,
Recording in progress.
Just wait 2 minutes. I am facing some network issue. Okay, so in the last class we have discussed about the decoder. Mainly in the last class we have started the discussion about the decoder and 3:8 decoder. So for the 3:8 decoder, I am here showing you the logic diagram of 3:8 decoder, and you already saw in the last class the truth table of 3:8 decoder. For the 3:8 decoder, you can know that there is 3 input and 8 output, and based on the 3 input, one of the 8 output is selected. Okay, so just 1 minute. I think the screen is visible for all of you now.
Yes, sir.
Yes.
So this is the logic diagram of 3:8 decoder. So here you can see that actually you already got the expression from the truth table earlier. So based on the expression or based on the truth table, actually the circuit of 3:8 decoder can be implemented using 3 NOT gates. So these are the NOT gates. Here you can see 1, 2, and 3. These are the 3 NOT gates, and 3 input AND gate. So these are the you can see these are the gates, and there are 3 input, that is A, B, C, are decoded into the 8 outputs, and each output responding one of the min term of the 3 input variables. Okay, so one thing here that is that the 3 inverter actually, so 3 inverter actually provides the complement of the inputs, and each of the inputs here, each of the 8 AND gates generate one of the min terms. Okay, and these decoders can be used for decoding any 3-bit code to provide the 8 output corresponding to 8 different combination of the input code. Okay, and this is also called the one of 8 decoder. Why it is called one of 8 decoder? Because because only one of the 8 output lines is high for a particular input combination. If you observe or if you remember the truth table for the case of 3:8 decoder, so suppose if hmm, suppose for an example, suppose when A B C equals to 0 1 0, so only the AND gate 2 has the high at all its input, and therefore this is the um, this is the y2, y2 equals to high. Similarly, if a b c equals to 1 1 0, so suppose if abc equals to 1 1 0, so which AND gate input should be high? When ABC equals to 1 1 0, in that case, which AND gate has the high inputs? From this, you can easily understand ABC equals to 4 plus 2, so 6. So y6 in that case, therefore high. Okay, and this is also called that binary to octal decoder, because the inputs represent the 3-bit binary numbers and the output represent the 8-digit in the octal number system. That's why it is also called the binary to octal decoder. So 3 to 8 decoder, it is called one of 8 decoder. It is also called binary to octal decoder. Is there any doubt whatever I have said? Hello? Okay. Now one thing, sometimes in some decoder, there is some enable inputs. So here you can see this is a you can see here enable inputs also there. So these enable inputs actually used to control the operation of the decoders. Okay, so with this enable line held high, the decoder function normally, and the input code ABC will determine which output is high. This is the main function, or this is the, you can say, the function of this enable here. Okay, and when the decoder is enabled, only if the enable line is high. Okay, so this is the concept about the 3 to 8 decoder. So is there any doubt for 3 to 8 decoder? This is the logic diagram of 3 to 8 decoder. You can see here, this is a 3 input and 8 output, y0 to y7. I am asking you, is there any doubt or it is understandable? Have you any doubt? Yes or no?
No, sir.
No, sir.
Okay. So next is that 4 to 16 decoder. I am not again discussing the 4 to 6 decoder because I already discussed the 3 to 8 decoder. It is always same, but from the name you can easily understand for the case of 4 to 8, 4 to 16 decoder. So this decoder has 4 input as well as 16 output, and you can easily understand the truth table also. So I am not here discussing the 4 to 16 decoder. Okay, so it is similar to 3 to 8 decoder, but the difference is that for the case of 4 to 8, 4 to 16, the input is 4 and the output is 16. Okay, so next is that one thing, that is the dual 2 to 4 decoder. What is dual 2 to 4 decoder? In the earlier class, I already mentioned the IC number of dual 2 to 4 decoder, that is IC 74139. So this is IC 74139. This is the for the dual 2 to 4 decoder. Okay, so for this case, I am here drawing the logic diagram of IC 74139. Suppose this is one decoder DMAX and the another one. Okay, so this is decoder or DMAX 1, and this is decoder DMAX 2. First I am drawing here, then I am explaining. This is 1A, 1B, and 1E bar. And this is 2A, 2B, and 2E bar. This is 1, 2, 3, and 4. Two, 5, 3. And this is same, that is 2, 0, 2, 2, 3, 2, 1, and 2, 2. So this is a logic symbol for dual 2 to 4 decoder. So from the name you can easily understand here the input is 2 and the output is 4. Actually, this IC 74139 consists of two individual 2 to 4 decoder or the multiplexer in a single package. This is the first 2 to 4 decoder, and this is the second. Okay, and each decoder has two inputs. So for this case here, you can see two input, that is 1A and 1B, and for the second decoder it is 2A and 2B, and 4 active low output. Okay, so 4 active low output. So these are the 4 active low output each decoder has, and 1 active low enable output. Okay, and this active low enable output can be used as the data input in demultiplexing application. This is the function here for the enable input. Now we will discuss, that is the BCD to decimal decoder. So for the case of BCD to decimal decoder, you have the concept about the BCD as well as the decimal BCD number system and the decimal number system. So I am here sharing the logic diagram of BCD to decimal decoder. Just give me few seconds to share the screen. Just 1 minute. Just just 1 minute. Just
Hello, sir.
actually, yeah, Anjan, tell me.
Yes, sir.
I think, yeah, actually, I have the picture, but there is a mistake. Okay, so that's why I am drawing the uh, figure for BCD to decimal decoder. Okay, so suppose For the case of BCD to decimal, first you see BCD to decimal decoder. So actually for here this decoder takes 4-bit BCD. 4-bit BCD as the input code and produce the 10 output corresponding in the decimal digit. That's why it is called the BCD to decimal decoder. And for this case, BCD to decimal decoder, the logic diagram actually, or the implementation for this purpose, actually the AND gate is involved. Okay, so here I am drawing. It is a little bit difficult or lengthy, you can say. So this is suppose D, this is C, this is B, and this is A. Okay. So first I am here drawing, you just see, then we will discuss the BCD to decimal decoder. Without the logic diagram, you cannot understand. This is the first output. This is suppose Y0. Y1. I am not drawing all the things. Okay. So actually, for the case of BC2 to decimal decoder, there is 4-bit BCD as an input code, and actually you will see in the output that is y0 to y9, but here I am not drawing the all the things. Okay, so here it is drawing that is y0 y1 up to y9. Okay, one thing, and this logic diagram. So this is the logic diagram of BCD to decimal decoder, and here you can see the AND gate is involved, and each output goes high when its corresponding BCD code is applied at its input. Okay, and the truth table, actually I am implemented this logic diagram based on the truth table. Okay, so you just observe the truth table from the internet. It is easily accessible. And one thing, when suppose for the example, here you can see that when the output, any output, that is y0 to y9, if anyone will go high, so particular the BCD when occurs at the output high, that's why in that sense the output will high. Okay, so this type of decoder is also called the one of 10 decoder. This is also called one of 10 decoder. Okay, why it is called one of 10 decoder? Because only one of the 10 output lines is high. Okay, and the subscript of the high output always equal the decimal equivalent of the input BCD digit. This is the part for the BCD to decimal decoder. Okay, next is that the BCD to 7 segment decoder or the driver. It is very important question in your I think you will get one lengthy question from this portion. So next we will discuss that is BCD to 7 segment decoder. I have discussed till now that is the BCD to decimal decoder. Now I will discuss that is BCD to 7 segment decoder. Before going to start the BCD to 7 segment decoder, I am requesting all the participants write your name in the chat box for the attendance. Still there is 2 to 3 students left who have not submitted their attendance. Okay, so I am ending this session, and after 5 minutes you just join with the same link. Okay.